class, this is Raji. In this video, we are going to learn about the oxoacids of phosphorus. See, you will have to learn about these many oxoacids of phosphorus. They will ask you the structure of these acids. It's too difficult to memorize the structure of all these acids. Okay. Yeah, along with that, you will be getting questions related to the basicity as well as the reducing power of this oxoacids. So we are going to discuss an easy method so that drawing the structure of this oxoacids will become so easy for you. Okay. Along with that, we will see some board questions also and questions from competitive exams also. So let's start. The oxoacids of phosphorus. See this one. You will have to draw and memorize the structure of 9 oxoacids of phosphorus. Out of that, 3 we are going to draw now. If you could memorize the structure of these 3, from this itself you can draw so many other acids also. See this one, orthophosphoric acid. You are familiar with the formula H3PO4. That is the formula for orthophosphoric acid. Always remember 5 bonds will be there around phosphorus. Okay. Now, whenever you draw the oxoacids of phosphorus, always a double bond O will be present on the head of phosphorus. You can remember that point also. Already 2 bonds have been formed by phosphorus. Now 3 more will be there. Okay. Out of 4 oxygen, we have utilized only 1. Now 3 more are remaining and 3 hydrogen also. Whenever you are drawing oxygen, try to attach it to phosphorus directly. Okay. And whenever you are drawing hydrogen, attach it to oxygen directly. Okay. If there is no other oxygen, then only we will attach hydrogen directly to phosphorus. Got it? So this will be the structure of orthophosphoric acid H3PO4. Now draw the structure of orthophosphorus acid. What will be the formula? 1 oxygen will be less, H3PO3. Okay, so 5 bonds will be there around phosphorus we said, and always a double bond O will be present on the head of phosphorus. Then how many more bonds will be there around phosphorus? 3 will be there. Okay, out of these 3 oxygen we have utilized only 1. How many oxygens are remaining? We will be drawing 2 oxygens. Okay. So, whenever you are drawing hydrogen, try to attach it to oxygen. Okay. So, out of these 3 hydrogen, we have utilized these 2. How many hydrogens are remaining? 1 hydrogen. That will be directly attaching with phosphorus. Easy. So, this will be the structure of orthophosphorus acid. Okay. Now, hypophosphorus acid H3PO2. 1 oxygen will be less compared to orthophosphorus acid. Okay. Now draw the structure. Phosphorus will be present and double bond O will be always attached to that. Then 3 more bonds should be attached to phosphorus. Okay. Out of these 2 oxygen, we have utilized only 1. So 1 oxygen will be directly attached to phosphorus. Out of these 3 hydrogen, we will try to keep hydrogen along with oxygen only. But here, no more oxygen. So due to that, we will have to attach the other 2 hydrogen directly with phosphorus. So this will be the structure of hypophosphorus acid. Easy. One more point to be remembered. See, hypophosphorus acid is also known as phosphinic acid, whereas orthophosphorus acid is also known as phosphonic acid. So in competitive exams and all, instead of orthophosphorus acid, you can see this name also. So that time we should memorize about this. Okay. In addition to that, you will be getting questions related to the basicity of these acids. Okay, what is basicity? 1 molecule of this acid can produce how many H plus ion in solution? Remember the hydrogen, that is attached to oxygen is the ionizable hydrogen, correct? No? Yeah, whereas the hydrogen that is directly attached to phosphorus, yeah, cannot be ionized easily, or it won't be getting converted into H plus ion directly. So how can you find out the basicity of this acid easily? So how many OH groups are there? You check it. That many H plus ion will be produced. Correct? No? So what will be the basicity of orthophosphoric acid? That will be 3. Why? 3 ionizable hydrogen is present. What will be the basicity of phosphonic acid or orthophosphorus acid? Yeah, here 2 OH groups are there. That means 2 H plus ions will be produced from one molecule of this acid. Okay. So what will be the basicity? In this case, basicity will be 2. Okay. Or we call it as a dibasic acid. What about hypophosphorus acid? Yeah, see, only one OH group is present. These hydrogens will not be ionizing as H plus ion. Only the hydrogen, which in turn is directly attached to oxygen, is the ionizable hydrogen. So what will be the basicity of hypophosphorus acid? Basicity will be equal to 1. Agreed? Yes. See this one. In addition to the basicity, you will be getting questions related to the reducing power of these acids. What is the condition for this acid to act as a strong reducing agent? A hydrogen should be directly attached to phosphorus. Okay. So in orthophosphorus acid, there is one hydrogen directly attached to phosphorus. Here also hydrogen is present, but that is not directly attached to phosphorus. Okay. So here one hydrogen is present. What about hypophosphorus acid? Here two hydrogens are directly attached to phosphorus. So compared to orthophosphorus acid, hypophosphorus acid is a strong reducing agent. What is the reason? It has got two hydrogens attached to phosphorus directly, whereas orthophosphoric acid will not act as a reducing agent. Got it? Now the question is that if a hydrogen is directly attached to phosphorus, how it can act as a strong reducing agent, or how it will be having reducing power. So what is a reducing agent? Reducing agent is a substance that will be undergoing oxidation. Oxidation can also be considered as the addition of oxygen. Now to understand, we will write an example of iodine and orthophosphorus acid H3PO3 in aqueous medium. We said that H3PO3 can undergo oxidation readily, then only it can act as a reducing agent. The oxygen that is present along with water will be readily accepted by H3PO3. Okay, so this nascent oxygen can be readily introduced in between phosphorus and hydrogen, and it will be getting converted into H3PO4 EC. Okay, so along with that, yeah, HI also will be formed. Is it clear now? Whenever a hydrogen is directly attached to phosphorus, easily it can introduce a nascent oxygen between P and H. Okay, so compared to H3PO3, H3PO2 will be acting as a strong reducing agent. Got it? You should remember this concept. Okay. Out of 9 oxoacids of phosphorus, we have drawn 3 acids already. Now, if you know the structure of orthophosphoric acid, you can easily draw the structure of pyrophosphoric acid. For that, quickly we will be drawing 2 orthophosphoric acid molecules. And from this, remove one molecule of water. What will be the remaining structure? That will be the structure of pyrophosphoric acid. So, 2 phosphorus atoms will be joined by 1 oxygen atom. Okay. So, this will be the structure of pyrophosphoric acid. Easy, no? So out of 9 oxoacids of phosphorus, we have drawn 3 in the previous page and 1 more. So you have learned 4, right? Now we are going to learn the 5th one also, 6th one also easily. Peroxo monophosphoric acid also you can write easily from phosphoric acid. Remember, peroxo bond will be always having 2 oxygen attached to it, right? So for this, you just draw the structure of phosphoric acid quickly. So this is the structure of phosphoric acid. So if you are introducing one more oxygen in between this O and H, it will become peroxo monophosphoric acid. Now how does it look like? Write and see. Yeah. See, in between phosphorus and hydrogen, yeah, there will be a peroxo group. Got it, no? So this is peroxo monophosphoric acid. Okay, what will be the formula? It will be H3PO5. Got it? One oxygen will be extra. That is the only difference. Now we will have to draw peroxo diphosphoric acid. Here also an OO bond will be present, and peroxo diphosphoric acid means two phosphoric acid units also will be there. So in order to understand, we are going to draw quickly two units of phosphoric acid. See this one, and from here we are going to remove these two hydrogen. So what will be the resulting structure obtained? In peroxo diphosphoric acid, in between two phosphoric acid unit, two oxygen atoms will be there, or a peroxo bond also will be there. Okay. So from orthophosphoric acid, we learned the structure of pyrophosphoric acid, peroxo monophosphoric acid, peroxo diphosphoric acid, and now one more you can learn from that. That is hypophosphoric acid. So this is the formula for hypophosphoric acid. For your exam, they will be giving the formula and will tell you to draw the structure of this acid. Okay. So there is one more easy way to draw that. Look at this one. From the formula itself, we came to know that, okay, two phosphorus atoms are present. So we can write two phosphorus atom. In all the oxoacids of phosphorus, double bond O will be present. And always remember, the structure of acid will be symmetrical. Left hand side also, right hand side also will be identical. Okay. Now, see this one. Try to keep hydrogen always along with oxygen. Two oxygen you have already utilized. Now I am using one over here. Okay, and hydrogen is attached to that. And here also I am using one OH. Total, how many oxygen we have utilized? 4. Two more are remaining. So we will draw oxygen like this. And how many hydrogens are remaining? 2 more. So we will keep that hydrogen also over here. All the atoms we have utilized. Then what we will do? So we will draw a bond between phosphorus and phosphorus. This is the structure of hypophosphoric acid. Easy, no? Yes. Now from orthophosphorus acid, we can draw one more acid. We will check it. See, this is the structure of orthophosphorus acid. We learned that already, and from that, we can easily draw pyrophosphorus acid. Okay. If they have not given the formula, how we will do that? Whenever you find pyro in front of the name of the oxo acid, you will have to write 2 units of that acid and remove 1 molecule of water. So quickly, we will be drawing 2 molecules of orthophosphorus acid. Now remove this molecule of water and you will be getting the structure of pyrophosphorus acid. See, this is the structure. What will be the formula? H4P2O5. Got it? Yes. So we have learned the structure of these many oxoacids of phosphorus except metaphosphoric acid. So we are going to learn that now. So let's see how is that. Metaphosphoric acid will be existing in 2 forms. Cyclic form also, linear polymeric form also. So both are having the same molecular formula. So how to draw that? Easily, you can draw 3 phosphorus like this. Okay, in between you should draw oxygen atoms also. Join all the atoms together. In all oxyacids of phosphorus, oxygen will be making a double bond with phosphorus. So that also we can draw. Okay, in addition to that, one OH also will be coming. Now 5 bonds are there around each phosphorus. Correct, no? Okay, now check this unit. That is HPO3. So cyclic trimetaphosphoric acid is a repetition of this HPO3 unit. Okay, that is the reason we are writing the formula like this. Now, linear polymetaphosphoric acid. While drawing this structure also, you can draw phosphorus atoms linearly. We know that double bond O will be attached to each phosphorus. You can join each phosphorus atom by means of an oxygen. Here also, each phosphorus atom will be joined by means of oxygen atom. To that OH also will be attached. Correct, no? So this will be a repetition of HPO3 units. So that is the reason we are writing the formula like this. So we have learned all the oxyacids of phosphorus. Now see the question. These are certain board questions related to what we have learned now. Draw the structure of H4P2O7. It was asked in 2017 paper. So we are not at all remembering anything about the structure of oxoacids of phosphorus, but still you can draw this. If you are remembering, certain points. See, in the formula they have given 2 phosphorus atoms. So you draw 2 phosphorus first. Always a double bond O will be present in oxoacids of phosphorus. Oxoacids in which 2 phosphorus will be present will be having a symmetrical structure. So if you are drawing one OH over here, here also you will have to draw another OH. Correct, no? Now out of this 2 hydrogen we have utilized. Okay, and other oxygens are also remaining. So I am drawing one more OH. Okay, on both phosphorus atoms. See, now all the hydrogen atoms have been utilized and 6 oxygen atoms also have been utilized. Then how many oxygen is remaining? Only 1 oxygen is remaining. That one we will connect in between 2 phosphorus atom. This is the structure of pyrophosphoric acid. Correct, no? In the same way, we are going to draw H3PO3 also, H3PO2 also. H3PO3. So here also you draw phosphorus, double bond O will be present, and again remaining oxygen you will have to draw. Try to keep hydrogen always along with oxygen. One more hydrogen is remaining. That one we will connect directly to phosphorus. And now draw the structure of H3PO2. Phosphorus will be present, double bond O will be present, and remaining 1 oxygen will be connected directly with phosphorus. Hydrogen we will try to keep it along with oxygen, and the remaining 2 hydrogen we will directly attach it to phosphorus. Yes, we got the structure of H3PO2 within no time. Now see the next question. What is the basicity of H3PO4? In this case also we need to draw the structure of phosphoric acid. Now what will be the basicity? How many OH groups are there? You check it. That many ionizable hydrogen also will be present. So what is the basicity? It will be 3, or it will be a tribasic acid, you can tell. Got it? Yes. See the next question. H3PO2 is a stronger reducing agent than H3PO3. Why? See, we have already drawn the structures. This is H3PO3 and this is H3PO2. We have already discussed that reducing property. It depends upon the number of hydrogen atoms which are directly attached to phosphorus. In H3PO3, only 1 hydrogen is attached to phosphorus. Okay. Here 2 hydrogens are attached to phosphorus in H3PO2. Due to the presence of 2 pH bonds, H3PO2 will be a better reducing agent, you can tell. Got it? Yes. See this question. This is a NEET question. Which is the correct statement for the given acid? So the question is related to phosphinic acid and phosphonic acid. So to save time, I have already drawn the structure of phosphinic acid and phosphonic acid. We have discussed it already. Okay. So the child should know phosphinic acid and hypophosphorous acid both are same. Okay. And phosphonic acid and orthophosphorous acid are same. Phosphonic, phosphorus, you can memorize like that. Okay, then if you draw the structure, you can answer this question. So out of these 2 acids, which one is monoprotic and which one is diprotic, they are asking. Monoprotic means it will be producing 1 H plus ion in solution. Diprotic means it should be having 2 OH groups and it will be producing 2 H plus ion per molecule. So phosphonic acid is diprotic acid. Phosphinic acid is monoprotic. So which one is the correct answer? The first one. Okay, that is the correct one. It's so easy for us now. Now see one more question. The strong reducing behavior of H3PO2 is due to. So we should know how to draw the structure of H3PO2. Okay, why it is reducing? We already discussed that due to the presence of these 2 pH bonds. So out of this, which one is the correct answer? The presence of 1 OH group and 2 pH bonds. Correct, no? The third one is the correct answer. Okay? Yes. We have discussed a very small topic, but hope you are confident with the concept of oxoacids of phosphorus and you can do any questions related to this. Okay, thanks for watching. See you in the next video.